Sure. I'll use your question, okay? Just I'm telling you formula. Okay. Because in these question we need to use Leibniz theorem. That is why I'm going to explain you this. Okay? We will do those question only. Leibniz theorem. Let U and V be two functions of x. Then nth order derivative of U into V is equal to NC0 into U to the power, like nth order derivative of U. Okay, U1 plus NC1 into U means n minus 1th order derivative of U into V plus NC2 n minus 2th order derivative of U and second order derivative of V. Okay. Plus up to NCN nth order derivative of Vn. In first we have nth order derivative of Un, and in last we have here nth order derivative of Vn. So let us do question now. This is formula. We choose V, which derivative soon become 0. Like if we have e to the power x, like if we have function, for example, as you have in your question, here, or you have y is equal to, x square into e to the power x. So how we consider which should be first or which should be second function? Obviously, we are taking derivative of u in decreasing order and derivative of v in increasing order. So we will choose v for that, which derivative will become 0 soon. So obviously, this will be repeated. E to the power, like derivative of e to the power x will be e to the power x itself. But if we take this v, then it will repeat and we need to take lots of terms. But if we choose v, this, obviously this will become soon 0. Okay. So we choose that function or that term as second function or as a v, that derivative becomes 0 soon. So this is, we will take this is u and this is v. Okay. You got? So let us find a derivative of y. So dny over dxn is equal to nth order derivative of product of x square into e to the power x. So you know very well how to find NC0, NC1, NC2. You know very well that, right? So NC0 into Vn, nth order derivative of un, or in some material they can give you like un here also, like they can show you nth order derivative of y as yn Don't do anything on the whiteboard. So they can show you like yn like this, or you can take un or vn like this also. Okay, not using only power, you can use here also. Okay, so you can use here also instead of power like this. un minus 1 un minus 2, and here also meaning is same, and here vn. So we will take here nth order derivative of un, and here we are taking u is equal to e to the power x and v is equal to x square plus nc1 un minus 1 into v plus okay, you need to prove it. Okay, you need to prove something. Into v, sorry, here v first order derivative of v, and here only v, just as nth order derivative of u and v, and here first order derivative of v, here second order derivative of v. Let me write a little bit more clear. V and nc2 un minus 2 into second order derivative of v. So let us find these terms. See, un will be e to the power x itself, un minus 1 also will become e to the power x, un minus 2. And let us see now v also. V first order derivative of x square 2x v1, v is equal to x square, and here u is equal to, we have taken e to the power x, and v2 will become 2 and v3 become 0. Okay, so we will take terms till here only, till here, because after that we will have 0, means derivative of v will 0. Okay, so nc0 is 1 into un is e to the power x and v x square. nc1 is n and un minus 1 is also e to the power x, and v1 is 2x, and nc2 yeah, nc2 is n into n minus 1 by factorial 2, or just 2 we can take n into n minus 1 over yeah, into this is same as e to the power x, and v2 is into 2. Let us simplify, and we can take e to the power x as a common, or we can write e to the power x into x square plus 2nx into e to the power x plus n into n minus 1, because they'll cancel, into e to the power x. And let's see what we need to prove. prove that? Okay. This is nth order derivative dny over dxn. Now everywhere we need to put n is equal to 8. Okay. Because we need this d8y over dx8. So put n is equal to 8. What we have? And we need to find second order and first and this also, because we need to show left hand side is equal to right hand side. Okay. N is equal to 8. So we will have d8y over dx8 is equal to e to the power x square plus 2 into 8 into x into e to the power x plus 8 into 7 into e to the power x. And we have finally e to the power x into x square plus 16x into e to the power x plus 56 into e to the power x. Or we can take e to the power x as a common. Inside we have x square plus 16x plus 56. Take this as equation 1. Now, let us take this RHS. So, second order, this is LHS and RHS 28 d square y over dx square. For this, either you can use like this formula for nth order derivative, or you can directly find second order derivative of the given function. Okay. Minus 48 dy over dx plus 21y. So 28 and d square y over dx square, we can use above formula also. Yeah, good evening. Are you getting me? Okay, so we can use above formula. Okay. So put everywhere wherever we have to here n, we can use 2. N is equal to 2. So e to the power x into x square plus 2 into 2 into x into e to the power x plus 2 into 1 into e to the power x minus 48 first order e to the power x into x square and plus 2 into 1 into x into e to the power x. And this will become 0 because n is 1 and n minus 1 will be 0. So obviously this term will be 0. So just leave it. And plus 21 y is x square into e to the power x. So let us simplify now. 28 into e to the power x into x square plus 4x into e to the power x plus 2 into e to the power x minus 48 e to the power x into x square and plus 2x into e to the power x and plus 21 x square into e to the power x. Now let us open the bracket. So 28 x square into e to the power x. Now let us 4 times of 28. So we have 128 12 x into e to the power x and plus 56 e into e to the power x minus minus 48 into x square into e to the power x and minus 96 x into e to the power x and plus 21 x square into e to the power x. Now let us simplify this. What we have? 28 28 plus 20. Yes, we have here x square into e to the power x. And now let us, because see, add them and just subtract this. So we have here only x square into e to the power x and 112 x into e to the power x and minus this 112 minus 96. So we have 16 x into e to the power x and we have 56 e to the power x. So let us take here e to the power x as a common. Inside we have x square minus 16x plus 56. And let us take this equation 2. So let us see our equation 1. 16 and what? Yeah, we have positive because we have 112 positive. So we have here positive. Yes. Okay. So from equation first and second, we can verify it. LHS is equal to RHS. So proved. Got it? So in this way, you can do this type of question. LHS is equal to RHS. Okay. Hence, we can show which they asked us. Like d8y over dx8 is equal to 28 d square y over dx square minus 48 dy over dx and plus 21y. Proved. Okay. You got each and every step? Okay. Now, question from exercise 5.3. Okay. Find the nth order nth derivative of the following. Okay. Let us do it. First question of exercise 5.3. Let y is equal to e to the power ax in bracket a square, okay, into x square minus 2na plus n into n plus 1 So let us take this is u and this is v. Why? Because after second order, this will become 0. Because these two terms are constant. Okay. So nth order derivative of y is equal to nc0, and we are taking e to the power ax, means nth order derivative of this, and vn let us take as such, plus nc1 I'm taking directly. Okay, if you have any problem then you can ask me. And e to the power a x means n minus 1th order derivative of e to the power ax. And now let us find first order derivative of this. So here we have c 2a square into x plus nc2 e to the power x means n minus 2th derivative of this, and here we have 2a square, because after that we have 0, means derivative of v will become 0. So here we have 1. nc0 is always 1, nc1 is n, and nc2 is n minus 1 by 2. So 1 into nth order derivative of a to the power x is a to the power n into e to the power ax into a square x square minus 2na plus n into n plus 1. This is n, nc1 is n, and a to the power n minus 1, because we are differentiating n minus 1 times, and e to the power ax into 2a square into x, and plus nc2 is n into n minus 1 over 2, and n minus 2th derivative of e to the power ax, that is e to the power n minus 2 into e to the power ax into 2a square. You got? Good. So now we have uh, a to the power n into e to the power ax. Inside we have a square x square minus 2na plus n into n plus 1, and plus 2 n into a to the power n plus 1 by adding them, into x into e to the power ax plus n into n minus 1 into a to the power n into e to the power ax. Now we can multiply this inside, then what we get? And this fourth question also. You want to ask fourth one also? Okay. So you can simplify this more further. Okay, just multiply this inside and take then common, okay, whatever you have. So shall you see into a square. Now you can do this question further. Just simplification you have. Tell me. If you can just, you need to multiply these terms and then take after that common, like you have e to the power ax and a to the power n plus 1 or n plus 2, whatever you have common. So just simplification further. Or you can leave here also. Okay, not an issue. If you leave here, then not an issue. You can leave here also. Okay, because we don't need to prove anything. So we can leave here also, or just take e to the power ax as a common from from all terms, because we have. Okay, that's like you can take e to the power ax as a common and can multiply a to the power n inside of this. Like then you will have a to the power n plus 2 into x square minus 2n into a to the power like n plus 1 plus n into n plus 1 into a to the power n. And plus 2n into a to the power n plus 1 into x plus n into n minus 1 into a to the power n. That's it. Okay. Or more, you can do, just take a to the power n plus 1 common from here. Okay. And a to the power n from here. So you can do this further. Tell me. So we can start the next question because it will take time. Okay, let's rejoin once again and we'll continue, okay, with that fourth question. All right.